Okay, sorry for the late start. Had trouble getting my machine to like this VGA. So I'm Will Hopkins. I'm the spec lead for JSR375. I'm going to talk about what's new in EE security, JSR375 and beyond. This just says that you can't really believe anything I say. So I'm going to start out talking about sort of where we are today with JSR375 and how we got here. Then talk a little bit about what's actually in the JSR, the APIs we're defining. Talk about what comes next. There are some things we didn't get to and other things we'd like to do, so hopefully there'll be a follow-on JSR. And wind up with some pointers to resources and any questions you might have. So this is the JSR375 expert group. There's myself, the spec lead, a lot of other folks on it, many of whom you might know, and several contributors. JSR375 started in early to mid 2014. There was a Java EE8 survey that showed strong support for security simplification and security interceptors. We took that and made a proposal for a JSR. JSR375 proposal was submitted and approved in late 2014. I think December it was approved. Expert group discussions began in the spring of 2015. We had a renewal ballot in the fall of 2015. From there until maybe the middle of 2016, there was not a lot of progress for various reasons. But in the fall of 2016, I was asked to come in and take the spec lead job from somebody who was transferring, which I did, and we had another renewal ballot to keep the JSR alive. We've started up discussions again and just published an early draft for review. That's actually out in review right now. The primary motivations were to simplify and standardize in terms of portability and modernize the APIs somewhat. There are a lot of different security mechanisms in EE today. There are container APIs, there's Jack, there's JASPIC, proprietary APIs in the different vendors' implementations. And particularly, there's a lot of proprietary configuration and management, which makes it difficult to arrange for security for applications. The EE containers define similar APIs in many cases, but with slightly different syntax. You've got HTTP servlet request as user and role versus EJB context as caller and role. Mechanisms like Jack and JASPIC can be difficult to use, particularly JASPIC. Jack is not so hard for the programmer, but tough to implement. And existing APIs don't leverage modern capabilities like CDI for the most part. So there was a goal to define simpler security mechanisms, implement them in a standard way across containers, and update the technologies that we used. The other sort of strong thread there is to enable developers to manage and control security for themselves. So there, previously was no standard portable mechanism for controlling how authentication happened. You could say you wanted basic or form in a web app, but you didn't get a lot of control over how the authentication happened on the back end. There wasn't any support for configuring and managing identity stores or for managing user roles and permissions. You could define what roles were, but you couldn't really assign them. There was no support for deploying custom authorization rules. So a second goal is to define portable APIs for authentication, identity stores, roles and permissions, and authorization. So the list on the left is what was originally proposed. The final spec that we have is not going to include all of that. So we're defining the first 4 items there. And basically the idea is we wanted to get something standardized in time for EE8 so that we could get a foundation in place we felt that these three in particular were a necessary foundation for cloud environments that are important these days. And not that the other things weren't important also, but this seemed like a good chunk of necessary foundation. And we had a good start on completing it. So the idea is to basically wrap that up and deliver that with the E8. What's left to do? The spec is currently in early draft review. We need to have that draft reviewed and incorporate the feedback we get. We need to prepare a final draft, final review draft with updated spec and code. We need to update the reference implementation, Soteria, to match the final API, integrate that with Glassfish 5.0, and write the TCK code and documentation. This is what our schedule looks like for the rest of the JSR. Early draft review is underway. The public review draft, public review period is from April 17th through the 16th of May, followed by a public review ballot, a proposed final draft on June 12th, and a final approval ballot from the 26th of June to the 10th of July. So, what's in the JSR? So there were some common principles that we were trying to adhere to. So the idea generally is to simplify things, enable developers to manage security, have the APIs work together so that one might delegate to another and they're composable where appropriate, and use CDI and annotations. The first API is HTTP authentication mechanism, and the basic idea there is that it's a simpler way to leverage JASPIC. So JASPIC is a pretty powerful mechanism. It's got rich functionality for authentication. It's even really broader than that. It's a message processing model, securing messages and validating messages. So it's very broad, very flexible. You can support about any token type or credential you could imagine. It can manage multi-hop conversations between client servers and third parties. And it's integrated into the servlet container via the servlet container profile. But it can also be difficult to use for some of the same reasons. One reason is that there's not a standard declarative configuration. So there is a standard configuration mechanism, but it's programmatic. And it's sort of a last one wins in terms of registering things, kind of a model, which is not always very deterministic. The other aspect of it is that you have to implement a lot of different interfaces and objects that you don't really care about if you just want to deploy a server authentication module with SAM. So the things you would have to do to use JASPIC today would be you'd need to write an auth module, which is the thing at the top right. You'd also need to write an auth config provider, which would be responsible for handing out auth configs, which would be responsible for handing out auth contexts, which is responsible for invoking on the SAM. So the piece you want to implement is just the top right part, the auth module. But all the other stuff that you have to code or configure is the bottom three boxes on the right. And on the left, if you want to have a standard way of configuring this SAM, you need to register it yourself, which may or may not have conflicts with other things that the container might register or other apps and things like that. So HTTP authentication mechanism is meant to address some of those issues. There's one interface to implement, HTTP authentication mechanism. You can deploy it with your application just by including it in the archive. You make it available via CDI so that it's known to the runtime, and then you tell the servlet container you want to use it by setting your auth method in web.xml to authmech. And so what you implement is just the thing that you care about, which is the module with the actual authentication logic in it. And the configuration is an edit to the web.xml. So the container is responsible for doing some things for you for HTTP authentication mechanism. One is that it provides a wrapper server authentication module. And basically this is a JASPIC SAM whose job it is to invoke the HTTP authentication mechanism that it injects through CDI. It's a standard thing. It can deal with any HTTP authentication mechanism because the interface is the same. The server also provides all the related objects that you need for JASPIC configuration. So there's an auth context, an auth config, and an auth config provider. It recognizes the auth method and arranges for all of that to be registered in the JASPIC factory for that application context. So all of the sort of heavy lifting for JASPIC, the container does for you behind the scenes. The interface mirrors the server auth module interface. So the wrapper is actually pretty straightforward in terms of what it needs to do. It just sort of delegates to this object it knows. So the validate request method gets invoked just as in JASPIC before the do filter or service method is called. Secure response is invoked after do filter or service, and clean subject is invoked in response to the application calling logout on its HTTP servlet request. That's the interface, at least as much of it as would fit on a slide, but it's the important bits. There's the validate request, the secure response. There are default implementations for a couple of those. So in many cases, all you'd need to implement is validate request and secure response, and clean subject have reasonable defaults. Identity store is the next API. So the idea with that one is easier identity management. So previously there was no portable way for an application to configure user stores. Every container did it differently. Identity store interface enables lightweight user store implementation. So there's a fairly simple interface, again, that you can implement if you want to write your own identity store that talks to a store that you understand. But there are also built-in identity stores. So there's annotation-based configuration for LDAP and RDBMS, which will result in a default implementation supplied by the container being instantiated for your application context. So in essence, it lets you sort of configure your own. The LDAP or the database has to be out there somewhere, but you can point your application at it pretty simply. The interface is intended for programmatic invocation, so it's a layer that could be used. The intent is primarily for HTTP authentication mechanism, but really any code that needed to authenticate users could use it. But there's no direct container integration in the sense that containers are not required to use identity store for anything. They're certainly allowed to, but they're not required to. So it has a pretty simple interface. There's a validate method, which will take a credential, a username, password credential, for example, and a method to get the groups for a particular user based on the principal. An implementation can support either or both of those methods. It declares which by what it returns from the validate type method. And that's either going to be authentication, meaning that it supports the validate method, or authorization, meaning it supports get groups by caller principal. The idea there being that authorization is typically based on group membership, or it can support both. And it has to declare a numeric priority for ordering when there are multiple identity stores. That's the identity store interface. It also has default implementations for all of its methods, really. The first one actually determines, so the type argument there is credential, but if you pass, for example, username, password credential, this default implementation determines whether the interface's implementation has a method matching that type, and if so, it invokes that method. And then there are sort of trivial defaults for the remaining three methods.
May I ask a question about
Sure.
like in CDI, if you have a lower priority number, that means lower priority. Because this is the opposite.
Mhm.
So what do you mean the higher priority? So
Um,
if you have two
mhm.
identities stored, then what do you do? Which
Right.
one is lower first?
So the lower number is higher priority. And I honestly can't speak to why that decision was made. It was made before I came on board as the spec lead, but that's how it behaves.
So that means a lower number will be, if you have two identities stored, the higher priority, which is lower number will be used. The other one, no.
It won't. If there's multiple, they'll all be used, and I'll get to that in a minute. Yeah. So the interaction with identity store is always through an identity store handler. Calling code invokes on the identity store handler and should never call identity store directly. Identity store handler delegates to the configured identity stores and manages invocation across multiple identity stores and aggregates the results. There's a default identity store that's supplied by the container. Applications can replace the identity store handler if they want to, if they'd like a different algorithm. But the default handler provided by the container is a fairly reasonable algorithm. So that's the identity store handler interface. You'll notice that there's only a validate method. The get groups by caller principal method is not exposed. It's meant for internal use as part of orchestrating authentication with multiple providers and wouldn't ever be invoked directly by external code. The result that's returned has a status, which is either valid, meaning that the credentials were validated, invalid, meaning that somebody tried to validate them, but they weren't valid, and not validated, meaning that there wasn't an identity store handler or an identity store that was willing to handle the credential or was successfully able to. So you get a status back. In the success case, the valid case, you also get the caller principal back, and you get the caller groups, if any. This is the algorithm for the default identity store handler. So it first constructs a list of the available identity stores, which is ordered by priority. Lower number is higher priority. And it iterates over that list, invoking the validate method for each identity store, where the type is either authentication or both, meaning that it supports the validate method. If any of the identity stores returns invalid, then we remember that result because we might need it later. If no identity store returns valid, then we return invalid if any previous identity store returned that status. Otherwise, we return not validated because it means that no identity store was able to attempt validation. Assuming that we got a valid result at that point, then we iterate over the list again, invoking get groups by caller principal for each identity store of type authorization. So that, just a sec.
You also invoke that for the ones which that said not valid, or only the ones that it said valid?
Only the ones that it said valid. So in step 2, we would have returned already if we didn't get a valid.
But there might be 2 that said valid, right? So then you call this for both of them? Or do
No,
you
for the first one. That's a good point. I left that out of this description, but the first valid we get, we break out of that loop.
Okay.
And then
So
we,
you don't aggregate them, okay.
correct. But we do make a second pass calling get groups by caller ID to get any groups that might be in other
I'm
stores.
still confused because you said for each identity store. If I have one that said valid, only then I go to step 3, right? And then I only have one. So
No, because the first time we only invoked validate on the identity stores that declared themselves to support authentication or both. The second pass is over the identity stores that declared themselves to be type authorization. So by definition, it's only the ones that we have not yet invoked. The idea is that you might authenticate credentials against one store, but then fetch user attributes from a different store.
Okay.
Yeah. So assuming we got past step 3, we return a result that says valid, and you'll have a caller principal and the aggregated groups. So you may have some groups from the identity store that validated the credential. That one's going to return the caller principal and might also return groups. And then you may have additional groups from the authorization identity stores that you invoked. So that's what it would look like if you had multiple identity stores and you invoke this through HTTP authentication mechanism. HTTP authentication mechanism will invoke on the identity store handler, which will iterate over the configured identity stores. And each of those are pointing at some user store. Yeah. Mm-hmm. This one? Yes. Mm-hmm.
Why you do an arrow on this way? Is it instead of doing a sequentially like identity store one first, and then identity store?
Yeah, so that's not a very good picture of the loop, but basically the identity store handler is going to iterate. In this particular case, it would iterate over the first 2 to do authentication.
Yeah.
And then in the second loop, it would only invoke on the last one there. But there could be any mix of authentication and authorization there, and it would iterate over the set twice. Or it might even make 2 different lists, right? It doesn't have to be one list, but it can either iterate over one list asking each time, or it can make 2 lists and iterate over one and then the other.
Exactly. I would put it into 2 lists according to the
Yeah.
type.
Right, so that's an equally valid implementation. Yeah. So there are annotations for the identity stores, an LDAP one and an RDBMS one. At LDAP identity store definition and at database identity store definition. They're modeled on the at data source definition annotation. The idea is that you would annotate some class that's visible to CDI, and during the annotation processing, it would cause an instance of the built-in identity store for either LDAP or database to be instantiated and populated with the configuration values that you specified in the annotation.
So this identity store can be injected into the CDI view?
Yes,
Okay.
identity stores are injectable.
All right, okay.
Mhm.
Okay, so this identity store is provided by the security JSR375.
Yeah.
This stack is implemented to provide this identity.
That's correct. So JSR-375 says that the container must provide a built-in LDAP identity store and a built-in RDBMS identity store. And then these annotations would be used to configure them and instantiate them. But you're not required to use those identity stores. You could implement your own if you wanted, and as long as you make it available to CDI, it will be used. Mhm. So that's the LDAP identity store definition. So one interesting question that would be useful for us to have feedback on is the extent to which people feel like this set of values is sufficiently rich to handle all the cases that people are likely to encounter. So we can't be all things to all people, and there are certainly environments where some fairly arcane configuration for LDAP can be required, but does this cover the, the basic requirements for the 80 or 90% case? So I'm not necessarily asking for feedback right now, but if people are reviewing the EDR spec, that would be a useful piece of information. This is the corresponding one for the database identity store definition. And databases are a little bit simpler generally, but again, the same question would apply. Is this sufficiently rich configuration? So identity store is one of the areas where we have some ongoing conversation in the expert group. One question is whether get groups by caller principal needs to be privileged or not. There's a pretty good argument that it's a dangerous method to have just sort of available in the container, especially injectable by essentially any bit of code. When you can basically hand it a principal name and find out all the groups that that principal belongs to. And you could even use it to poll a user store and say, is there a user account for John? Is there a user account for Joe? Is there a user account for Lucy or Frank or Sally? And that's a pretty big security hole, really. So one solution to that is to require that the calling code is privileged to invoke it, either always or when Security Manager is enabled. And then the other change that's under consideration is to pass something other than a caller principal to get groups by caller principal. That would obviously require changing the name of the method. But the idea is that in some environments, a caller principal isn't going to be enough to uniquely identify the user. So would we want to pass in, for example, the credential validation result, which would have not only the caller principal, but also perhaps a unique ID or a user DN or some other bit of information that would help the identity store, number one, recognize if it was a user that it knew anything about, and number two, disambiguate the user, accurately identify the user so that you make sure you return the right groups for the user as opposed to the groups that belong to some other user with the same name. And lastly, it might make sense to return a set rather than a list of groups. SecurityContext is the last item that we're working on for this JSR. The idea behind SecurityContext is to provide consistent access to security information across containers. So today, the various containers implement context objects and methods for access to security. You've got get user principal and HTTP servlet request, is user enroll, authenticate. EJB context has very similar methods, but they have different names. So SecurityContext is intended to provide a consistent interface across different containers for this sort of information. And also an extension point for adding security functionality. At the moment, it has three methods: get caller principal, is caller enroll, and authenticate. But we expect more methods in subsequent JSRs. Authenticate, by the way, only works in the servlet container. It's essentially dependent on the HTTP servlet request authenticate method. That's the interface. The additional parameters on authenticate are basically a way of providing a little bit richer input and a little bit richer response reflecting what you might be able to do with an HTTP authentication mechanism and, for that matter, with JASPIC. So JASPIC has a model where authentication might need to continue. because you've just sent a challenge to the client and the client has to respond, that sort of thing. So servlet, HTTP servlet request.authenticate will return true or false depending on whether you need to, whether you should expect that you're going to continue or not, but it's not very rich in terms of the information that it gives you.
What's the idea of the last method without the request?
I'm sorry?
The idea of the last method without the request?
I'm sorry, I didn't catch that.
So there is the last method without the request.
Yes.
So what's the interface for this?
Oh, so I think the assumption there is that the request is available from the CDI context at that point. That's a good question, though. I'll have to go back and ask Arjen that.
For the security context, currently in the CDI spec, you inject, you have to provide a principal key.
Mhm.
You inject
Yeah.
principal. The principal is kind of implemented by the security context that follows the principal.
Mhm.
With this, in the introduction of the security context, do you think is there any more enhancement to the principal, or are there any more additions? I mean, will this make the security context to injectable as well?
So I think security context should be injectable. I don't know off the top of my head if it is now or not. That's a good question. The existing APIs aren't going to go away, and honestly, I don't think we've looked carefully yet about at the interaction between CDI and security context in that environment, but the broader notion is that get caller principal and is caller and role should return the same results as you would get by calling in a similar method in a different container. So I haven't thought through the CDI case specifically, but the servlet container case, the EJB context case, the results should be the same. And this spec doesn't require a particular implementation, so it doesn't require that that this gets the principal from the CDI context. It doesn't require that the CDI context get the principal from security context. Similarly, for servlet container or EJB context, the requirement is that the behavior be the same, and the containers get to implement it however makes sense on that platform.
Okay, for the EJB war case, so you expect to get the security injected subnet context or injection EJB context?
I'm sorry, yeah.
For the EJB
Mhm.
in the war, so this
Oh.
is the kind of the, we have could have EJB also this kind of subnet context.
Right.
So for this security context, do you expect to get from the HTTP server?
Well, I think it depends on the context in which it's invoked, because the current implementation uses CDI to inject the relevant context object. So depending on the context that you called it, you'd get a different context object and inject it and return a different answer. But that's something we probably should look at in terms of what one it should be. On some level, I think it's probably moot. It's certainly moot for the caller principal, because you are who you are, right? The principal won't be different depending on the calling context, unless somebody's pushed it on the stack. As far as roles, Jack has a lot to say about context IDs and role mapping and things like that, so we would want to be consistent with what Jack says there. So I made this point already, but containers are free to choose the implementation approach that they want to use. It's JSR-375 is really trying to specify the behavior in terms of what containers do now. So we're not trying to necessarily, at least with these methods, define new behavior, but define a consistent interface to existing behavior. Authenticate provides slightly richer functionality than the servlet container, and at the moment has sort of an implied contract with HTTP authentication mechanism in terms of signaling that it does back and forth between the two to sort of emulate the JASPIC message flow behavior. So that's what's in 375. Next, I'm going to talk a little bit about what might come after. So there's a number of ideas that we have for that. So completing the remaining items from the original JSR is obviously one of the things we want to look at. We've also had features requested by the community and features that we think are sort of implied or driven by cloud and microservices use cases. The first four on this page we expect to have been done in 375. So the remaining ones would be password aliasing and role permission assignment and authorization interceptors. The most recent Java EE survey came up with a pretty strong result showing that OAuth II and OIDC ranked as the third most important technology that people wanted to see in Java EE. So we took that as a pretty strong clue of what people want us to do there. In terms of cloud-driven features, secrets management and encryption, I think, is one of the most important ones that isn't already on the list that cloud use cases are driving. So password aliasing, I think, is probably a subset of that. But secret management is crucial for cloud deployments because you often need secrets and keys of one sort or another. And you need to be able to securely store them and retrieve them and manage them. And do this while you're deploying to a cloud that may or may not have services that support that. And then you need to be able to use them securely once you're managing them. So you need to be able to do encryption and signing in a secure way. So I'm not going to talk a lot about details of OAuth II, but basically it's an authorization and delegation framework. There's some RFCs that define it based on existing work defining token types. One particularly interesting / challenging thing about OAuth II for Java is that there's multiple identities involved. So there's a resource owner, which is not necessarily the same entity as the client that the server is talking to. And then there are two different servers involved. So it's not just sort of a client-server model, but there's a client and a resource server, and there's a client and an authorization server. And again, the client and the resource owner aren't necessarily the same person. And that presents some challenges in terms of the Java model where you're sort of presumed, any request is presumed to be executing with a particular subject. But in fact, you might be talking to one entity, but having to authorize access on behalf of some other entity in the course of OAuth. One last thing to note, authorization is represented as scopes, which in some senses can be thought of as similar to roles. This I'm really not going to talk about at all, partly because it's an eye chart and partly because it's a lot of complicated stuff and we don't have a lot of time. I'd need to look at all these very carefully to explain them. But in terms of the implications for what Java EE needs to do, the basic requirements are you've got an app, you've got a couple of resources that you want to protect. You've got some client that's trying to access those resources. And again, the client may not be the actual owner of the resources on the back end there. So a number of things have to happen for that to work. You've got these resources. There's this external authorization server out there. The application needs to be able to create the OAuth resources because the authorization server needs to know about them so that it can authorize them in terms of issuing tokens with scopes in them. And the app needs to be registered with the authorization server for that purpose. The client also has to register and update the scopes that it's interested in. Then it needs to execute an authorization flow, getting an access token for those scopes, and optionally a refresh token. Then it calls the application on the server, passing the token. The server needs to validate that token and get the subject. And then it also needs to think about, okay, so now I've validated the token, how do I represent that internally, and how do I model the access grants that are implied by the scopes in the token, given who I'm talking to. So on the server side, how do I register OAuth resources? How do I indicate my scopes? On the client side, how do I register my OAuth client? How do I know what scopes to ask for? How does my client get tokens? How do I handle token expiry? Can we abstract variations in authorization servers? So every implementation of an authorization server is a little bit different. They are often configured differently so the tokens have different attributes in them. Is it possible to abstract that in a sufficiently rich way without making it overly complicated? And how do we deal with scopes and clients and resources at scale? So some ideas would be on server side, annotating resources to be secured so that a lot of that process is hidden from the implementer, and you just annotate your method and the caller either gets in or doesn't. Annotate whether a resource needs basic auth or OAuth II. For OAuth secured resources, standardize a scope declaration, standardize a resource registration with an authorization server. That might be a tough one given that we don't necessarily, unless we're going to build a Java EE authorization server, that one's going to be hard to do. Or adapt to specific authorization servers and document auth methods and scopes. Client side, life cycle to handle client registration, static or dynamically created clients, secure management of client ID and secrets, discovering capabilities on targets for constructing scopes in token requests, and abstractions to acquire tokens. OAuth II flows as strategies, token expiry handling, expiration to inject tokens on invocation. So those are things that we could look at doing for OAuth. OAuth, again, seems to be the sort of most requested feature. Role and permission assignment has a use case. Applications may want to manage its users or externally managed users, and may need to assign roles to users or groups based on an application-specific model. Users or groups assigned to roles changes based on deployment. Representations changed based on what identity store you're bound to. And OAuth II scopes versus roles. Is there overlap there? Are they the same thing? Are they complementary? So those are questions that would have to be answered. Some ideas would be to support deployment descriptors and change the binding at deployment based on configured ID stores. So at the moment, role bindings actually do happen a lot of times in deployment descriptors, but they're proprietary deployment descriptors. So, WebLogic.xml has some role bindings, but web.xml does not. Assigning scopes to OAuth II resources to roles. So that would enable an app to bind scopes to roles and mapped users and groups may change. Authorization interceptors, the use case there is that the application must restrict access to functionality, and roles by themselves are too coarse-grained, and we need, or the use case requires, application business model that determines rules to drive access. There's no consistent interceptor for policy enforcement. There's no consistent externalizable rules, and it needs to be bindable to changing identities by business and operation. So if you hardwire a bunch of rules based on specific identities into your application, that's going to be pretty brittle over time. Some ideas to address that are standardizing on some interceptors, allow security teams to build custom authorization logic with some externalized and standardized rule language, and make it identity and security context aware. Secrets, use case for that is application needs to be able to securely manage secrets. That might include passwords for resources like an OAuth client ID and secrets. Applications are able to secure secrets in a portable way. They aren't stored in clear text. Values can change and be bound per deployment, meaning that you have an application that has a reference to some secret, but when you deploy that, the actual value of the secret might be different. State needs to be externalized, or at least externalizable. An application may consume secrets from a key management system. And there's more and more of those showing up in clouds. So some ideas there. Applications refer to secrets via aliases. That's similar to the password aliasing feature that was earlier talked about. Those could be configured via annotations or deployment descriptors, and have a life cycle where you bundle an alias and a value as a secrets archive with the application, or bind values to aliases at deployment, possibly from an external key management system. And you would need tooling to manage secrets in an archive or elsewhere. Another thing that we could look at is relying on PKCS12 support in java.security.keystore. So that's basically the content of the presentation. Here I've got a list of things you could look at if you're interested in more information. We've got the JCP page, the java.net project. The code and the spec are actually out on GitHub at the moment. We have a GitHub project. There are a couple of mailing lists. You can join the users list at java.net. There's also the expert lists, which you could send to, but it's moderated if you're not on the expert group. Everything on the expert list is copied to the users list. So if you join the users list, you'll see all the expert list traffic as well. And we do have a Twitter feed. If you're interested in contributing, certainly the most important thing or the most valuable thing at the moment would be to look at the EDR spec draft and provide feedback. You can download it from the downloads page on jcp.org and send comments to the users email list. If you're interested, you could also join the JSR as an expert or a contributor. Again, comments or suggestions to the users list are welcome, or come and talk to me or to any of the other expert groups that expert group members that you may know. And that was all I had. Any questions?
Have you looked at OpenID? That's quite a popular security.
OpenID Connect, I think. Yeah. I thought I had a slide on that. I guess maybe I didn't. But yeah, along with OAuth II, I mean, the two are highly related because OpenID Connect is built on top of the OAuth II protocols. So doing OpenID Connect sort of presupposes that you've got some level of support for the basic protocols already in place. But Yeah, that's absolutely an authentication mechanism that we think is important.
With this spec, with this JSR375,
Mhm. Mhm.
and the implementation, the RI, do you think it's kind of complement with OpenID Connect or the competition?
I think they're in a different space. So the HTTP authentication mechanism, you could use that interface to implement an HTTP authentication mechanism that could do OpenID Connect. So you could implement OpenID Connect by writing an HTTP authentication mechanism. So they're complementary in that sense. But this spec does not define or require support for OpenID Connect specifically. I think a follow-on JSR, that's something we'd want to look at very carefully. We would want to look at how do we provide support for consuming, at a minimum. There's a lot of stuff we talked about here in terms of what you could do on the client side and the server side, but at a minimum, I think on the server side, the REST container needs to be able to consume an OAuth token and do something useful with it. And I would say that serverless container and any other HTTP-based container you'd want to be able to consume an OAuth token that happened to be an OpenID, an ID token as opposed to an auth token, right? But again, a lot of the underlying protocols and token types and things like that are the same. It's a different spec. It's one of the token types that OAuth and therefore OpenID support. JWT is the one that I've seen most commonly used. Yeah.
That authorization model based on groups seems to be pretty coarse-grained, right? I mean, you left out permission modeling of your spec because you wanted to somehow have something there, but
Right.
Authentication seems to be pretty complete, but authorization seems to be half-baked at best.
I think that's true, and I think it's actually a little bit unfortunate that we've got the word authorization in there at the moment. So the identity store includes authorization as one of the things that an identity store can do. My view is that that's a misuse of the word because it's not really doing authorization, it's fetching attributes. Right, so you might use those attributes later on to do authorization, but it's not right.
Really good, right? I mean, I can't say, oh, no, I have a request there with some business parameters. Is that you are authorized to do that? This, at best, gives me some building blocks to implement it. But
Exactly, and I'm actually having this conversation at the moment in the expert group. And so it's possible that may change. But yeah, I agree 100% on that. Anything else? Thank you for coming.